Hi guys, it's me, Cloud, and I need your help. We have to save Tifa, and the only way we can do this is by teaching me how to dance. Yeah, that's right. Y'all are gonna have to teach me some sequences in order to dance correctly. So, let's begin. So, how is this series 6 plus 11 plus 16 plus dot 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 plus 81 represented in summation notation? So, what we can do first off is we can see that the jump is plus 5 for each of these. So if the jump is plus 5, that means my slope must be 5. So that means I can eliminate these. And then we'll say, well, let's look at where we have to end, because the only difference between these two is that we got 14 and 15. So let's plug in, well, yeah, let's just go plug it in. So 5 times 14 plus 6, and let's see if that gives me 81. So times 5 is going to be 20. It's going to be 70 plus 6 is 76. That's a no-go. So hopefully the last one works, because otherwise we got ourselves a serious problem. So 5 times 15 plus 6, 5 times 15 is 75, plus 6 is 81. Boom. That is correct. And it's nice because not only do I know that this is correct, I know everything else is wrong. So we win. Cue victory noise. There you go. And then let's see what this sequence has taught me how to do. Oh my goodness, that's so amazing. All right, let's see what's next. So next up, we have, one second. Let me open this up. All right, so here's our next question. Ooh. Here we go. Let me blow it up a little bit. Blow it up a little bit. All right. So write the following series in sigma notation. Okay. So we know that this, we're going to go ahead and I'm just going to go ahead and say n equals 1 to start us off. We know that the jump is plus 5 each time, right? So we know that it's going to be 5n. Now if we plug in 1, we get 5, but we want to end up with 4, so we go minus 1. And if this is the first term, second term, third term, we want the fourth term, then we need the top to be 4. Let's see if that makes sense. Plug in the last one. 5 times 4 is 20. 20 minus 1 is 19. So yeah, that's right. You know what it's time for. Time to cue up victory music. Nice. What sequence does this teach us? What does this show me how to do? Oh my goodness. That was amazing. I'm learning how to dance so well right now. It's absolutely stunning. Let's keep going. All right. Let's see here. What's the next question? The next one is find the numerical answer to the summation given below. Okay, so we need to find the summation from 1 to 71 of 6n plus 1. So we know the summation formula is S is equal to N over 2 A1 plus AN. So if we're going from 71 to 1, we know that 71 minus 1 plus 1 is going to give me 71, which is the number of terms. So we have 71 over 2 number of terms, or 71 number of terms, so 71 over 2. A1 is the first term, so if we substitute in 1, we get 6 plus 1, which is 7. If we substitute 71 in for n, we get 71 times 6, which is 420. Ooh, 4, it does not like me. 426 plus 1, which is 427. Okay, looks like I had some issues here. Let's see if I can move this back up. Not good. Well, that's fine. Let's keep going. So this is what I get. Apologize for this. This is just plus an. Cool. No, we can still solve this. So this bottom part's going to clean up. It's going to be 14(3), 434, 71 over 2. This is pretty nasty, so I'm going to go ahead and just type it into a calculator. I can easily divide this by 2, but I'm still going to have some problems here, so let me move myself over here, and let's just type this in. Let's just see what we get. So 71 divided by 2, multiply that by 434, and I get this beautifully large number as my final answer. Awesome. I'm curious, what amazing dance move does this one show me? Let's find out. Oh my God. So amazing. Let's keep going. All right, what's up next? Hold on one sec. All right. I know what you're thinking. Why did we not hear the awesome music? You're right. I should have played some victory music. 1 second. Let me play victory music. Because we're always winning here. We're always winning in pre-cal. All right. Let's do the next one. So if a sub 1 is 10 and an equals a, okay, so this is a recursive sequence, then find the value of a5. Okay, so this is telling me that the first term is, hold on a second. Weird. Okay, nah, it's okay. So this is telling me the first term is 10. Now this formula just says you keep adding 5, right? So you just go 10 plus 5 is 15. And then we're going to add another, this will be A1. So A2 is just plus another, we're just adding 5. This would be 15 plus 5. But to streamline the process, we're just adding 5 every single time. So the next one's going to be 25, then 30. And I want to go up to the 5th term, so I got to need one more, 35. And if you wanted to go through and add 5 like so to each of these, like directly writing it out, nothing wrong with that. And if you want to write them out, there's nothing wrong with that. But that's all we got to do. And so A5 is 35. And there's your answer. Once more, cue the awesome music. Yes. Now, what amazing dance move are we learning next? Amazing. I know. You can't wait to see what's next. Neither can I. We're learning so much today. It's so exciting. Let's do the next one. I apologize for the pausing. There's a little technical issues here that I got to work through for every problem. But we're getting through it. Getting through it. Next one. I see what the problem is. Okay. So the next one is, sorry, I'm kind of blocking the problem. Find if a sub 1 is 2 and a sub n plus 1 is an squared plus 1, find a sub 3. So we're just going to plug it in. So we're going to say, we're going to plug in 2 squared plus 1, and this is going to give me my new term, which is a2. So a2 is going to give me 5. And then, as a recursive, you just substitute it back in. So it becomes 5 squared plus 1, which is 25 plus 1, which is 26. So a sub 3 is 26. That is what the question is asking for. There is my answer. So remember, what this is saying is that if a1 is 2, you plug 2 in here, this will give you this value, and then which becomes 5, and then you substitute it back in, and you just keep spiraling it in over and over and over again. All right, so hopefully that makes sense. You guys are awesome with that. And we get to, that's right, cue up the awesome music. Love it. Oh, wait, that's not the dance move. Here's the new dance move. So good. So good. Let's look at the next one. Being the problem. You have to make yourself worthy of viewing the awesome dance moves by doing the problem. Actually, by doing the problems, we reveal how to do the next dance move. That's the game that's being played right now. Yeah, I know. It's fantastic. I'm loving this too. Might as well be like, ba-da-ba-ba-ba, because I'm loving it. Let's go on to the next one. All right. There we go. All right. So now we're going to go in reverse. So write a recursive formula for a sub n, the nth term of the sequence 5, 1, negative 3. So we know the formula is roughly a sub n equals a sub n minus 1 plus d when it's arithmetic. And we were only playing with arithmetic thus far. So let's see here. What are we adding each time? Well, 5 minus 4 is going to give me 1. And if you don't see this, right, all the d is technically n plus 1 minus 1, an, right? So you take the previous terms and you subtract from the first one. Or if you prefer, like so, okay? In other words, 1 minus 5 is negative 4. I'll write it down. 1 minus 5 is negative 4, just to be clear. And you can see that works for the next one. So just to emphasize the negative 4, there's my sequence. That's all I got to do, okay? Awesome. Yeah. Once again, dropping it. So good. That's right. All right. What amazing dance move is going to be learned now? Let's see it. Ooh, he moonwalking. He moonwalking. Nice. I know. You're enjoying this probably more than I am. All right, let's see what the next one is. I know. Y'all want to jump straight to it because you can't wait to see what's next. All right. Let's see. Ah, it didn't show. What's going on here? We're going cray-cray. Let's try it again. There we go. Sorry, I don't preload these because I never know how much space I'm going to need to do these. All right. Which recursive sequence would produce the sequence 2, 3, 7? So this is interesting because 2, 3, 7 is definitely not arithmetic, right? Because it's not increasing by the same amount. But if I'm giving you the first term and I'm giving you the sequence, we can definitely figure this out. So for the first one, we have 4 a sub n minus 1, just means plug in the first term. And this will give me 8 minus 5, which is 3. So if the first term is 2, next one's 3. That's good news. So we're going to plug in 3. 4 times 3 minus 5 is 12 minus 5, which is 7. So that looks pretty on point. The first one seems true. Now, for just to make sure, I can always try the other ones. Okay, so the other ones, I'm just worried about not having enough space here. Let's see if I can fit it in here. So the next one's going to be, if I do negative 5 times 2 plus 4, this is going to become negative 10 plus 4, which is negative 6. So that's already a no-go. Let's do another one. And then we get 3 times 2 minus 3. So this is 6 minus 3, which is 3. Okay, that is good for the first one, so interesting. Let's do the next one. So the next one we take 3, plug it back in. 3 minus 3 minus 3. This gives me 9 minus 3, which is 6. But I want 7, so that's a no-go. So even if it doesn't work for the first, you can't assume that just because it works for the first one, it's not going to work. It's going to work for the second one, right? We got to work it all the way out. All right. Let's do. I've lost my mouse. Let's do the next one. We'll do it in blue. All right, let's see if I can fit it in here. So we got negative 3 times 2 plus 3, which is negative 3, but I want positive 3, so I already know it's a no-go. I thought the first one works. I worked them all out just to make sure, and it absolutely does. So you know what time it is. It's time to win. All right, sorry. It's not even the dance. What is the dance? Let's find out. Ooh, nice. That's a great dance move. That is a great dance move. I love it. Let's see what we got next. Let's see what emerges from the mathematics to lend us to some additional awesomeness. Let's see what's next. Can't wait. All right. So next up we have f of 1 gives me 10, and we're asked to find f of n. If f of n equals f of n minus 1 minus 4, then we want to find f of 5. Okay. So this is essentially saying that if I want to find f of 2, then it's f of 1 minus 4. But we know that f of 1 is 10, so this is now 10 minus 4 will give me f of 2, which lends itself to giving me 6. So f of 2 is 6. So then we repeat the process. Now we got to get all the way to 5, so we're going to now take 6, we're going to subtract 4, and this is going to give me f of 3. F of 3 is 2. Now, you may see that the first one, so let's be clear here. F of 1 is 10, f of 2 is 6, f of 3 is 2, right? So what does this tell you? Well, this tells you exactly what this formula is telling us, which is that we're just dropping it by 4. So we know f of 4 is just 2 minus 4, which is negative 2, and f of 5 is just minus another 4, which puts me at negative 6. And if I'm looking for f of 5 is negative 6. And there we go. Which means, that's right, victory is ours. Time for some victory music. Oh yeah. Yeah. I'm losing my shoulder pad here. It's so good. All right. What amazing dance move could be next? I know. I'm just as curious as y'all are. Let's see what we learned. Whoa. Whoo! If that's not classy, I don't know what is. Let's go on. I have a feeling this next one is going to be epic. All right. Next question. Well, actually, why don't I do this the smart way? Scroll up a little bit. And now when I cut and paste, it won't be so messy. Yes. Okay. Here's the next one. I know. I'm looking forward to it as well. Let's blow it up a little bit. All right. So the next one. F of 1 is 1. F of n plus 1 is equal to f of n squared plus 5. So this is just saying that if I plug in the first term, which is 1, so rather, let's put it this way. If I want f of 2, then that is equal to f of 1 squared plus 5, right? Because 1 plus 1 would yield 2, okay? So you take what you're given, which is 1, square it, add 5 to it, and this is going to give me 6. So f of 2 is 6. And then if we're looking for f of 3, we just repeat the same process. So we'll do a different color, make it stick out. F of 3 is just f of 2 squared plus 5. So f of 2 is 6, so it's 6 squared plus 5, which is 36 plus 5, which turns out to be 41. So f of 3 is 41. We win. You know what? Let's spice it up. Let's listen to Barrett sing our victory song. Wow, that was not very emotional. Hey, it's okay. I got you guys. We learned a new dance move. Let's see what it is. Ooh, this one looks amazing. Amazing. I call it the table. Ooh, we get it a double dose. The table. Amazing. All right, what's next? Let's see what's next, y'all. Next up, we got all right, so a sub 1 is 3, a sub 2 is 2. We're looking for a sub n equals 2a sub n minus 1 minus 3a sub n minus 2. Harder to say than it is actually to do. So what we're going to do is if we're looking for a3, right, a3 is 2. Now 3 minus 1 is 2, so this is a sub 2 minus 3 minus 2 is 1, 3a sub 1. So basically I'm going to rewrite this as, well, I guess I'll change the color here. A sub 3 is 2, a sub 2, now a sub 2 is 2, and a sub 1 is 3, so we're really just playing the game of plugging and chugging, so it's 4 minus, I wrote 6, what's wrong with me? 4, really, what's wrong with me? 4 minus 9, and this gives me negative 5. So a sub 3 is -5. Now we're trying to get to a sub 5, so we're going to repeat the process. A sub 4 is going to now notice is 2 minus 1. So what we know we got to do here is we're going to go with the one that's closer, just -1 is 3 first, and then 3 a sub 2. So we'll substitute it in. So 2 a sub 3 is -5 minus 3 a sub 2. A sub 2 is from the beginning was 2. Okay, so I've moved on from a sub 1. I don't care about that anymore. We got -10 minus 6, which gives me -16. So a sub 4 is -16. We'll conclude with a sub 5, which is 2 times it's n minus 1. So a sub 4, a sub, well, I guess write it out, right? 3 a sub 3. Okay, so this is 2 a sub 4, we found out earlier is -16, minus 3 a sub 3, we found out here is -5. Not too bad. So this is -32 plus 15, because negative is a plus. So 30, let me put it this way, -30 plus 15 is -15, but it's 2 more, so I guess technically bumped down to becomes -17. And there's my answer, and there it is. So it's just a matter of just reading this carefully, and you'll be fine. So the value of a sub 5 is going to be -17. All right, it's time for the original victory music. All right, that was kind of an abrupt ending. Apologize. What awesome sequence of dance moves does Cloud learn now? Let's see. What is this? Oh, I get it. It's a cartwheel. Brilliant. Man, this is just too brilliant and amazing. All right, let's see what's next. That was epic. Epic. I don't even know. It's not, I don't know what's better, the math or the dancing. Let's see what's next. Let's see. Okay. So, you know what? That's not the one that I want to. Let's go to this other one. Apologize. This is not what we want. We want this one. Okay. Okay. So it says write in a recursive sequence that I'm blocking it. That represents the sequence defined by the following explicit formula. So we know when it's written as an explicit formula like this. This is a. Well, let me put down here because it doesn't like me to write over things. A1 plus. They put d in front here, so I'm going to go ahead and do that. D minus n minus 1. So this is the equation that we talked about in class that you really need to know. And d is 3, right? So we know that the difference is 3. If I want a sub 1, this is just 1. This goes away. It's just -9. So we know that's -9. So we were working for the recursive, so this would be a sub n minus 1 plus -9, because all we do is add d. And so that would be pretty much what it is. Why did I write -9? Sorry. Bah, silliness. This is not -9. The difference is 3. So I should have said plus 3. I don't know. All this dancing's making me go crazy. All right. But now that I've done it correctly, I am worthy of victory music. So good. You know, the only thing better than that? The next dance move that we're going to learn. What is it going to be? Let's find out. Wow. Dancing! Amazing. Amazing. I know. You just wish this would never end. Me neither. Good thing. We got more problems. Thank goodness. All right. What's next? What is next? In short, winning. What do we have here? Write an explicit formula that represents the sequence defined by the following recursive. You know what? I keep getting these problems that I really don't need. I apologize. Let me actually pull up the next one. It's not reading it right. There we go. All right. So here's the next one. Write a recursive sequence that represents the sequence defined by the following explicit. Okay, so this is interesting because normally we're just getting some number. Now we're getting 4x. So, well, we know how to figure out the first one. We'll just plug in 1, right? So a sub 1 is going to equal to x plus 4x times 1. Notice it's the n that's changing. So the first term is actually just x plus 4x, or simply 5x. That would be my first term, right? Now, how do I figure out what's my equation going to be? Well, what we could do is you can figure out the next term, right? But we also know that the value in front of n, which in this case is 4x, is the difference, right? Because this is still an equals a sub 1 plus dn minus 1, right? Or just n in this case, but still fitting in the format where d is 4x. Now you got to remember d is 4x. So this formula is going to be an equals a sub n minus 1 plus 4x. There you have it. Also keep in case they ask, I don't think they're asking for this, but right, the first term is still 5x, but we have that right there. So yeah, you're fine. Okay, so I guess it's got some victory. All right, let's listen to a different version of Barrett singing, because Barrett could do better than last time. Let's listen to what he has to say. There. So much better, Barrett. So much better. All right. Let's see what I got next. What is the next dance move for Mr. Cloud? Yes, Mr. Cloud likes to refer to himself in third person. Don't judge. Stop with the judging. All right, what's next? I feel like he's going to open up. Such openness. All right, there's your next dance move. Just so, you know, it's like words can't even express how beautiful that is, you know? That's how I feel, at least. Just epic. Epic. Epic's not even good enough for it. Let's see what's next. All right. So the next one is write an explicit formula that represents the sequence defined by the following recursive formula. A sub 1 equals negative 8 and a sub n equals a sub n minus 1 plus 3x. Well, okay, so if we're kind of like reversing what we've been doing. So we know that this is our d, so we know d is 3x. We know the first term is negative 8, so how can I write this? Well, the formula is a sub n equals a sub 1 plus n minus 1 times d. So this would be negative 8 plus n minus 1 times d, which is, I'm blocking it, 3x. So make sure there's no negative signs. And so we got a sub n equals negative 8 plus 3xn minus 3x. And that's pretty much it. That'd be your answer. So I think either of these are correct according, let's see here. Yeah. They're actually just leaving it like this. So that's the way the key is. I'll double check these, so either way you're fine. Either way, you're getting victory. So you know what that means. Cue traditional victory music. There you go. There's your victory music. But more importantly, you want to see what the next dance is. Me too. Let's look at it. That is so beautiful. All right. Let's move on. What's next? What is next? What's on the agenda for the next level of winning? Let's find out. So, oops. Let's do that again. All right, seem to be blocking things. Write a recursive sequence that represents the sequence defined by the following explicit formula. Okay, so if this is explicit, that means that's code for this is just an equals a1 plus, they would like to put d in front for whatever reason, dn minus 1. D is negative 3x. So if I want to figure out the first term, just plug in 1, right? And so 1 minus 1 is 0. So all of this goes away, and I'm left with just 2. So the first term is 2. Now if I want to figure out the recursive, well, the recursive is just an equals a sub n minus 1 plus d. We just said d is negative 3x. Watch that negative. So minus 3x. And that is our answer. Pretty straightforward. Okay, so I hope everybody's doing okay with that. And I hope everybody's doing okay with so much winning. What could be the next dance move? I don't know. Let's find out. What's next? I know. I guess you could say clouds put a perfect spin on this situation. Let's move on. All right, what's next? What is next? I can't wait to see what's next. I know you can't either. All right. So we got find the 59th term of the sequence. Okay, so we know the formula is a sub n equals a1 plus n minus 1 times d. And so 26 obviously is the first term. We're looking for the 59th. And the difference would be whatever the difference is between these, right? So 26 minus 17 would give me the difference, which is 9. So times 9. Perfectly set up, so it's just 26. So this is 58 times 9. So 58 times 9 is 72. 45 is 52, so that's 522 plus 26, so this is what, 8, 4, 548. Beautiful. Beautiful 548. There is our answer, which means oh, sorry. Y'all are like, what about the dancing, right? I got you. So much beautiful. Oh, he did it twice. I'm learning so much. Oh, I guess I'm doing it twice too. Goodbye. Like a bird flying. Tifa's going to be saved so well. So well. Forgot what's the next one. Oh, this is what? 59th? Okay. Next one is find the 13th term of the arithmetic sequence 4x minus 9, x minus 16, negative 2x minus 23. Ooh, this might look a little tough because they're all in terms of x. Sorry about that. I was getting a little too excited with some dance music there. Well, look, they're giving you x's. We know the difference is still... Okay, back to the problem. We know the difference is still the difference between the two first terms, or whatever sequence of terms that you want. So it's going to be, we're going to do x minus 16 minus 4x minus 9 to figure out what's the difference between the terms, right? Because we want to figure out what we need to subtract to get to the value. So in fact, let's think about it this way. You're taking 4x minus 9, you're going to add some d, and that's going to give you x minus 16, right? That's basically what we're saying. So we're going to take that and move that over there. So when we do that, let's do it in a different color. D is going to be equal to x minus 16. Now when you subtract, it's a quantity. So 4x minus 9. So x minus 16 equals negative 4x plus 9. And put together like terms here. So we got an x and minus 4x gives me negative 3x. And then we have negative 16 plus 9, which is negative 7. And so now we know our d is just that. So we know our difference. We're trying to find, so this is going to be, this is our d. Now the equation, if we think about it, if it's an equals a1 plus n minus 1d, right? We know our first term. Our first term is 4x minus 9. We're looking for the 13th. So n's going to be 13 minus 1. And we just solve for d, right? Which is negative 3x minus 7. So this will give me a13. So let's get a13. So this is going to be 4x minus 9 plus 12 times negative 3x minus 7. Go ahead and distribute and use some new colors. So negative 36x plus, was that 1484? I'm going to double check my signs because that's where I make my mistake, and I did make a mistake. For whatever reason, I was thinking 12 is negative. So this is actually, let's clean this up. This is minus 84. Okay, and we got 4x minus 9 here. And so we're going to put the 4x and the minus 36x together to give me negative 32x. Negative 9 and negative 84 is going to give me what? Negative 93. A13. Boom. You know what? Da, 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 da. But more important, time to see some dancing. Ooh, this looks like an extension of what I did before. Oh wait, this was what I did before. Ah, wrong one. Let's pull the right one. I guess that one was so good I wanted you to see it 3 times in a row. Something's not right here. This is the one I'm looking for. I put this. Oh, this one's epic. Y'all ready? Y'all ready for this? Oh, into your screen. God, he's so good. All right. All right. So, to get through the last ones, we got to get through 3 more problems. So, here we go. Home stretch. I know. It's sad that the end is right around the corner. So tragic. All right. So find the numerical answer to the summation. So this is summing from 3 to 68. Okay. So remember, the summation formula is S is going to equal to n over 2 a1 plus an. So how many terms do we have? Remember, it's top minus bottom plus 1. So this is 68 minus 2, which is 66. I just cleaned up that first. So I got 66 divided by 2 terms, because they're pairing, right? And then so it's, how do we figure out the first one? Well, the first term is just going to be if you plug in 3. So this is 21 plus 5, which is 26. Okay. To figure out, we have to move cloud. Otherwise, the answer might come out nebulous. I know, so much awesomeness at once. So this is going to be 7 times 68. Ooh, plus 5. Okay, so 7 times 8. Mido and Fido can do tricks. 8 times 7 is 56. Carry the 5. 6 times 7 is 42. Plus 5. What did I say? 42 plus 5 is 47. Plus 5. We got 481. Yep. Now, this is getting ugly. I mean, I know it's 33 plus this, but let's just put it in there. I am just blocking everything today. So I am going to type it in as 33 because that's what it is. And then I'm going to be lazy here and just do 26 times 481. Don't judge. Okay. Be the only time you're judging. Definitely not judging the dancing. It's just so epic. And this comes out actually as a pretty epic answer too. So we get some pretty huge number, but that's okay. 16,731. I mean, you're adding up a lot of numbers, right? So it makes sense that it's going to come out as big. Cool. Let's look at the next one. I know. Used to hearing that winning noise. Actually, you know what? We've done this one. I don't need to worry about this one. Yeah, we've kind of done that one too. You know what? We don't need to do the other ones. They're more of the same. You know what we need to see? We need to see some dancing. But first, let's do one last time. One last time. Victory music. The drums. So sad. So sad it's over. So sad. But you know what's not over? The dancing. Let's see it. Let's see it. This is the last move. Well, kind of went on something else apparently. All right, here's the last dance move. Let's see what it is. Oh, yeah. Victory pose. It's like a victory pose. Okay, well, very cool. So what did all of this do? Well, this allowed Cloud to, being me, to do the ultimate dance. Now he's learned it. Let's see what happens when we put it all together. So there's me. That's me and Cloud. Let's see what happens. Let's see. Let's see how good my dance moves are when they get them all together.
I think you're going to follow my lead.
Oh, yeah, I can. Amazing! Oh, look, it's the table. It's the table. Oh, stretch. Thanks to y'all. Look at that spin. Y'all taught me that. Oh, look. He's going cuckoo. Look at the cartwheel. Nice. Remember when y'all taught me that? Yeah. Victory pose. Hey, it's because of y'all. All right. I'm looking forward to your nice moves in the next test. Good luck, guys.